Hello everybody, and welcome to my iterative policy evaluation algorithm demonstration. I have prepared this demonstration in Jupyter Notebook. The reason is that I have a previous assignment from my reinforcement learning class, and I would like to present an algorithm from there to you. Before starting with my presentation, some fundamental needs are necessary, and unfortunately I cannot give all of them in this 5-minute presentation. Therefore, I created this another 5.5 minute video that you can find in YouTube. I will be dropping also a link to that. So the algorithm that I picked is iterative policy evaluation, which is practically dynamic programming, and it is one of the methods of reinforcement learning, and actually maybe I should say one of the basic one. I would like to say a couple of words about reinforcement learning. It is one of three methods of machine learning, the other two being supervised and unsupervised, and the main characteristics of reinforcement learning is an agent-environment interaction. So in reinforcement learning, we have an agent that is trying to learn from its environment, and for that, the environment feeds the agent with situations. An agent takes those situations, evaluates them, and returns back to the environment with an action. Then again, environment takes the action and returns a new state and a reward for the action of the agent. Returning back to the assignment, I need some documents, some files. Therefore, I started with checking them if they are in my coding environment, and I proceeding from there. The algorithm starts with this basic iterative evaluation. Based on this Bellman equation, we iterate over states and calculate values for our new states. So we have an initial state, and then we create an updated state. By iterations, we repeat this process again and again to improve our state values. And in this process, we are using the rewards returns to the action of our agent. We keep doing this to a point where we believe that we converge to the optimal state as our best state. This is a 3x4 grid world. We have two terminal states here and there. The top one provides a reward of 1 and the bottom one provides -1. We have a barrier here, and our initializing starting point is right at this node. What we will be doing is creating this grid world, trying to find our way from here to there. After we create the grid world, we are initializing our nodes with zeros, and in the beginning we are creating a policy, and this policy here telling our agent what to do exactly. The agent should be going up from here and right and right and right, and it will be ending up here at this positive node. But in case if it would be going to the right, not up, then it will be ending negative rewarded end state. Now when we run our algorithm, it calculates, starting from the terminal points, this one is a positive and this one is a negative, which path is the best path to end up the episode. So far what we have done here is the Bellman equation, and when we take this a step further and mix it with the greedy policy, our agent will be examining all of the options and will be start picking the best options until it finishes the approximation. Even though it is provided with a bad policy, which is suggesting to turn right at the very beginning to take it to the negative end state, it finds the correct way to end up with the positive end state. As you may notice, here and here, these nodes are suggesting to the agent to end up in the negative end state. Now they have been changed, as well as this one, because the agent wants to end up in the positive end state, and when it goes up from here it cannot, and when it goes right from here it cannot, so eventually it turns back and takes this route to go to the positive node. With the update rules, our new policy is designed as this, and our new states values have been changed all to positive, because from all states our agent can find a way to go to the positive reward end state. For this assignment, I get the help of the reinforcement learning book of Southern and Bardo, and I also found their courses in Coursera given by their assistants, Mr. and Mrs. White. If you would like to, you can find the book online, and also you can visit this course as well. Thank you very much.